On this handout, the first side you don't need to do anything with grapher unless you'd like to. You just need to solve them, take the derivative implicitly. Yeah? On the back side there's 3 problems, right? Just 3? So I'm doing one of them, so that leaves you only have 2 left, so it's not a lot of problems. Here's how I want you to do them. First, solve for the derivative implicitly, and then we're going to use grapher to show our work, and we're going to type it up real nice in Microsoft Word. So first we got to solve it by hand, unless you want to try to do it in Microsoft Word, which I guess that's your choice. So let's take the derivative implicitly. So the derivative of x squared is of course 2x. Then here we've got to use a product rule. So we're going to go, there's a plus in front, nice. So first, derivative of the second. What's the derivative of arctangent? 1 over thing squared plus 1, and this time we're going to have to multiply by y prime because we're doing an implicit derivative and we're doing the derivative with respect to x. So that's dy dx. Okay, that's the first half of the product rule. I've still got to finish it. So plus, the big plus from the product rule. Second, derivative of the first is real easy. It's just times 1. I'm going to write it down. Okay, so that's the derivative of the left-hand side. Derivative of the right-hand side is going to be pretty simple. Derivative of y is y prime, and that goes away to 0. Right? So we've got y prime in 2 spots. What are we supposed to do then? Get it on one side, factor it out, all that business, right? So I'm going to put this one over there, but I'm going to write it first right here. So y prime, if I subtract this one to the other side, it's going to be negative x y prime over y squared plus 1, correct? If I subtract this chunk to the other side, and then equals, so this stuff's already all on the same side, so I'm going to say equals 2x plus inverse tangent of y. It's already all on the right side by itself. Cool? I did some flip-flopping of sides, but you just got to be consistent. So I thought of this going over there, that's now this side, and then these guys are now already there. Okay? So now we got to factor out the y prime. Instead of writing another step, I'm just going to erase it right here. Factor it out. What am I kind of missing if I do this correctly? Oh, you guys are getting lost, okay? I'll do another step. It's dangerous if you're at all getting lost. So y prime, factoring it out, is 1 minus x over y squared plus 1 equals 2x plus inverse tangent. And now divide by that chunk, and we've got our derivative. It's not pretty, but we're going to call it good this time. So here we go. So there we go. There's an expression for the derivative. These problems, though, ask you to create the derivative and then use it to get the tangent line in a certain spot and show that that is all kind of working out together. So I need to evaluate that. So I'm going to say, I'm going to switch notations and go dy dx, evaluated at the point. Remembering that notation. And I can just plug stuff in and see what happens. So we got 2 times negative pi over 4. Someone, I'm going to need a calculator in a second, if you don't mind, plus the inverse tangent of y. Y is 1 over 1 minus x, which is negative pi over 4, and then y is 1 squared plus 1. So I'm going to simplify some of this before I hand it to my calculator. That's going to be negative pi over, negative pi over 2 plus inverse tangent of 1 would be something we should do in our heads. That's 45 degrees. 45 degrees has an inverse has a tangent of 1 over 1, right? And then down here I've got 1 plus, down there I've got 2, right? So that 2 of course goes with the 4 right right there, so I've got negative pi over 8, so it's really minus a minus is plus pi over 8. Oh, I can keep simplifying. Without a calculator, I'm going to do that. So these have a common denominator of fourths, so I'm going to go times 2 times 2. So that's negative 2 pi plus pi over 4. Common denominator down here is 8. So that's pi plus 8 over 8. I'm going to flip it. That's really just negative pi right there over 4 times 8 over pi plus 8. That's going to be 8 over 4 is 2. And that's about as simple as I think it's going to get, so we can add that to our calculator. Okay, you guys should be trying to do this stuff. I think it's in the realm of all your potentials, and it's necessary for being good at math and engineering and whatever later, so definitely it's good practice. So what is this approximately? Can you guys tell me?
Negative 0.564.
564. Okay. See, I want the exact form of the answer when I create the tangent line, because if you put this in for your tangent line, is your tangent line going to be perfectly tangent? It sure isn't. And if you leave it up here, like, God, that slope's going to be terrible, right? Like, you can't really work with that. This, I think I can probably work with it as a number. So let's see. So let's go back and get our tangent lines, and then we'll go to Grapher and plot those. So I've got y minus, what's my y value for this point?
1.
Okay, equals the slope. That's our derivative that we calculated and worked hard on right there. Hopefully I didn't make any mistakes. X
Plus pi over 4.
plus pi over 4. Thanks, Courtney. So that, I think, we could enter in Grapher, because Grapher, unlike a graphing calculator, has the ability to deal with implicit functions, which is pretty nice. So if we were going to put it in our graphing calculator, we have to, of course, do what? Add the 1. I don't even think you need to distribute. You can just add the 1. Okay? So we're going to stick those two things in our graphing in Grapher now and see if everything's looking right. We'll know immediately if I simplified wrong there. Anybody see a mistake I made? You guys were catching me earlier. I didn't see one. Well, we'll try it out, and then we'll go back and fix it if necessary, okay?